All right, so let's get started. So in the next around 40 minutes, we will dive a little bit deeper into the more advanced patterns in TypeScript. So short introduction to myself. My name is Christian. I've been working as a software engineer for like the last 14 years. Started with Java back then, and when Angular 2 was released, I switched over to more of a full stack role. And now since like 7-8 years, I'm developing also in the front end with Angular, TypeScript, JavaScript, but still in the back end with Spring and the whole ecosystem. I also do some trainings on the side for these topics. Also really like to speak about TypeScript and Java on conferences. And I also recently, like 5 months ago, started to do a YouTube channel where I show the same stuff which I show you today, but just like in smaller videos. And you can find all the stuff on my website, type.rocks. There is also a link to the GitHub. There is a link to my YouTube channel and also on LinkedIn. If you're interested to get in contact, just visit my website. So if you have questions, you can ask them all the time. You can just go to type.rocks/QA. There is like, you can put your question in there, and then at the end of the talk, I will answer all of them. And if we don't have enough time to answer the question, then I will answer them after the talk, and you can just come back to the page later and see my answers. So yeah, let's start with the expedition. So we will talk about 5 topics today, and the first one will be about mapped types. So let's say we have a type here, events, and let's say we have an add property and we have a remove property. Now let's say we want to create a user actions object, and let's say we call the type here on events. Now we want to have for each of the events properties an on function. So let's say we have an on add, which is a function, and on remove, which is also a function. Now, how could we define such an onEvents type? What we could do, of course, is we could say we have our onEvents type here, and we could say onAdd, which is a function, and onRemove, which is also a function. Now, the issue with this is that as soon as we change the events, then we have the issue that this onEvents does not have to be updated. So these 2 types are no longer in sync. Now, how could we change this? We could use map types for that. Now, the first thing we do is we have to extract the key types of these events. So how can we do this? We say we have an event keys type here, and we say key of events. Now what happens here, when we see what we can put in a variable which has these types, we can see here we're only allowed to put in remove, add, or move. Now we can use this union type to create this mapped type here. So we just remove these fixed values and we map over our event keys. So we say key in event keys, and you can name this key variable here whatever you like. I just like to call this key to have like a speaking name to it. Now as a value, we say this is just a normal function as before. Now we can see here our onAdd does no longer compile, because now we have to name the properties the same way as our events. So we remove this, and we have our onRemove changed to move. But now we can see we get an error in our user actions object, because now it's necessary that we also add the move property to it. So let's do this. We can see we also have auto-completion, and let's add it like this. Now, the disadvantage of this is, of course, that we are now not having this on prefix and this uppercased first letter. But we can fix this because we can map over this key here. So we can say as, and then we use backticks. And with backticks, we're using template literals. For everyone who is using JavaScript or TypeScript, this is like the same way you can work with strings in these languages. So we can say we have a prefix of on, and then we use our $ and curly braces, and we can access our type in here. And now we can see we have now the possibility to add here on, and we can see now the code compiles again. So you're not restricted to having exactly the same key, but you can mutate them and make them look like in a shape you like. Now the last thing we need to do is we need to uppercase this first letter here. How can we do this? We can use a so-called intrinsic type, and we say capitalize here. Now, when we check what capitalize here is, this is a so-called intrinsic function. Now, intrinsic functions are types which are defined in the TypeScript compiler. If you have other types, like for example, return type or omit or stuff like this, you always see what TypeScript is doing when you click on the type. But here it's done in the compiler itself because it would be too complex to create such a type for us developers. And now we can see that we have to change this to uppercase, and we can see we have now exactly the same as before, but this on events is now completely dependent on this type events. So when I change, for example, remove to delete, I have to change this down here, otherwise my code will no longer compile. By the way, all the code I will show you today can also be found on the TypeRocks GitHub page. So if you'd like to, of course, you can take picture, but you of course also can copy paste it later. So this is like a simple way of using map types, and we will now look a little bit more into it, what you can do with these template literals. So let me show you how this works. And let's say we have a type here, and let's call this type RGBCSS. And we say this is an alias for a string. Now let's say we have a valid RGBCSS type variable, and we type this RGBCSS. We now say RGB 1, 2, 3 like this. And this should work perfectly fine. But we want that this one, let's call this invalid, does not compile when we don't have this RGB in the right shape so that it's valid CSS. Now, of course, currently this is not the case because we just have a string as an alias. But we can use template literals to achieve this. So we use backticks here, and we do the same as we did with this on prefix. We say we want to have an RGB with parentheses, and in there we only allow numbers, and we only allow exactly 3 of them. And now we can see that line 5 does no longer compile because we now made sure that we have exactly 3 numbers which are separated like this. So when we row this, we also see that RGB12 is not assignable to this type. So you can specify exactly how your string types have to look like. You are not restricted to only say only you want a string, but you can exactly tell how they have to look like. For example, when you have a phone number, you can also say that you want to have, for example, a plus in the front and so on. Now, we can combine map types with template literals. So let's say we want to create like a small CSS validator. Let's say we want to have a gap type here, and we say this is margin or padding, and we say we have a gap position, and this is either left or right or top or bottom. And now we could, of course, create this combination ourselves, but we can use map types to create a combination of our gap type and the position. So we can say type here, gap CSS, and now we use backticks, and we say the first thing we are passing in is our gap type connected with our gap position. And TypeScript now creates for us all the possible permutations of this gap type and gap position. So when we check this here, we can see we get margin left, right, top, bottom, and padding left, right, top, bottom. So we don't have to do this manually ourselves because maybe we misspell something, maybe we forget to add like one position, so we don't have to do this. Now we can make this even better. We can also make a type for the size. So let's say we create this type here, size type, and we say this is either rem or let's say here pixel or percentage. And now we say our size CSS is also a template literal, and we say we want to prefix this with a number, and the suffix has to be of size type. Now we have created this gap CSS and size, and now we can connect them using mapped types. So we say here we have a margin padding here, and here we create again, like with our brackets, we say that our key has to be in gap CSS, and the value is size CSS. And now when we create such an object, we can see that, for example, if I type the letter M, we have the auto-completion for margin left, bottom, right, top, and for padding. Now let's use margin right, and as a value, I have to choose, for example, 1 rem. If I remove one letter here, we can see that the line does no longer compile. And the same happens also, for example, if I remove the dash here, we can see I also get an error. Now, we see that we get an error here on line 16 because that some properties are missing. Because currently our map type tells TypeScript we want to have each of the properties we need to have each of the properties also in our object here. But we can fix this. We just add a question mark here to tell TypeScript we don't want to have to add all the properties we've defined there, but only certain ones. And by using this approach, we only would have then to update, for example, the gap position or gap type once, and then it will be reflected in all the other types we are deriving from them. So in my opinion, really cool, because then this is much less error prone than updating all the stuff yourself all the time. Now, let me show you something else. Let me show you a type which you maybe never have used before, pun intended here. So, and let's say we have a hello string, and this is hello Øredev. Now, of course, this works because this is a string. But what happens if I change this to never? We can see we get an error because string is not assignable to the type never. Now, we all know how to fix this. We just say as any, and this should normally work, right? But in this case, this does not work because even any is not assignable to the type never. Now, why does this not work? Only never is assignable to never. So this means everything else cannot be assigned to the type never. So why is this important and why is this useful? Well, let me show you an example. Let's say we have a type here, locations, and we say this is either Zurich or this is, let's say, Stockholm. And let's say we have a function here, get country for location. And we put in our location, and we say we return our string. Now, we want to have for each of the locations we pass in the country returned from this function. Now, you could, of course, use if else, but I will use the switch case in this case. And we have location here. And now let's say we have our case here for Stockholm. We say return Sweden. And we can see here that we get an error because our string here is not satisfied because it also could return undefined in case we pass in Zurich, because the switch case is not handling the return value, does not return a string when we pass in Zurich. So we have to handle this. We have to say Zurich here, and we say return Switzerland. Now we can see here this works perfectly fine, and we could stop right there. But let's think about if you are writing this code, for example, in a library. And this library is used, for example, also from a JavaScript environment. And when we call it from JavaScript, people could do stuff like this. They could call it with anything they like when they don't have types or they don't have JS-doc. So this means if I run this code, we can see I get back undefined. So maybe sometimes this is okay when we get back undefined, but when we have like code which is really important for our program, we should also, of course, add runtime safety. So how could we make this also runtime safe? We add a default case, and we have a throw new error in here, and we say location is not known. Now, when I run this, we can see I get an error, Paris is not known. Now, this is okay, but let's say we go back into our code later and say, okay, I want to add this location. I want to add Paris. I add it in here. And now I use it, for example, in TypeScript. We can see here we have now an issue that we don't get a compile time error anymore because TypeScript figures out, okay, Stockholm and Zurich is covered, but the location here can be Paris, of course, but this might be fine because the developer has added a default case for this, so I will not show him that he has forgotten to add this branch. But we don't want that. We want to only have this like as a safety net if something goes completely wrong. For example, if somebody does not use the TypeScript compiler correctly. And this is where we can use this never type. We can say we have a variable here, and you can call this anything you like, but I call this variable here exhaustive and say the type is of type never. And now we do something interesting. We assign location to this type. Now what happens here? We can see we get a compile time error because string is not assignable to type never. Now what happens here? The TypeScript compiler sees Stockholm and Zurich is covered, so the only type we're missing is the Paris string here. So location at this position can only be Paris for TypeScript. But because you are not allowed to assign anything to never, which is not never itself, it will throw an error. So what you now can do is we say, okay, we fix this. We add Paris in here. We say return France. And we can see the error goes away because TypeScript now figured out that the only way we could even reach this part, this default part, is basically never. Because never is like this part which shows TypeScript this is a branch which basically should never be reached. So because of that, we now have compile time and runtime safety. Now we can make this even a little bit better because we have this variable which is unused. So we can remove this and we can use the satisfies keyword. So satisfies is used like this. We say location satisfies never. And in this case, this checks if the location type here is satisfying the second type we pass in. And this does exactly the same. This keyword was added, I think, in version 4.6. So before you had to do it the other way. But let's say I remove Zurich here, we can see we get an error again. So by using this approach of this exhaustive switches, we have an easy way of having compile time, but also runtime safety. Now, of course, this also works for if we switch this to if-else. So if, for example, I remove one case in here, one check, we can see this still does no longer compile. So you don't have to use switch cases. You can, of course, also use if-else. And I think this is a really nice approach because you don't have to sacrifice one safety for another. So you don't have to sacrifice the compile time safety for runtime or vice versa. So the next thing I want to show you is about recursion or recursive types. So TypeScript itself also uses recursion to build certain types, but I will show you one which we can build ourselves. And let's say we have a type here, RGB tuple. And RGB tuple is a fixed length array. Basically, tuples are nothing else than an array which are only allowed to have a fixed length. So let's say we have an RGB tuple variable here. And we say 1, 2, 3, we can see this compiles fine. But as soon as I add another element to it, we get an error. When I remove one element, we also get an error. So, by the way, if you're using tuples, you could always use push or pop on it. So they are not really like these fixed length arrays. To fix this, you can use read only because this removes the possibility to use push or pop on this tuple. Of course, only in TypeScript. In JavaScript, you could still, of course, use it with as any. So, but we have this read only, and this works fine. But let's say we want to do something more complicated. Let's say we want to have like an RGBA type, which allows 3 elements or 4. Then we would have to do the following. We would have to wrap this in read only, and we would have to copy this over and have to say 3 or 4 elements and add another element to it. And this now is okay, but let's say you have like a fixed length array of 10 elements, or let's say 10 or 20 elements or something like this. You would have to count them all manually. So wouldn't it be nice if there was like a type we had in TypeScript, let's call this tuple, where we could pass the number of elements which are allowed in there and then the types which are allowed. Now we can see TypeScript does not provide such functionality, but we can create them ourselves. So the problem in TypeScript types is that it does not support for loops. Like you can't like stream over any types. You have to do this recursively. So how would we do this when we would program this in pure JavaScript, but also recursively? We would say we had like a function which is called tuple, and we have the length we want to pass in, which is here in our case 3. We have the type we want to allow, in our case number, and we would have an accumulator, like an array which we will build up until it has the size we'd like to have our tuple to have. And we would initialize it with an empty array so that we don't have to pass an empty array when we start iterating. Now we would say if the length is equal to the length of the accumulator, in this case, we just return our accumulator. Otherwise, we just call the tuple again with length, type, and we would create a new array, spread our existing elements into it, and add a new one. Now we can code this exactly this way in types. So let's create a type for that. And let's say we have a tuple. The first generic argument is, we call it length. The second one we call type. And the third one we call ACC for accumulator. Now we can say this is of type array. So we tell TypeScript this type we have here is always an array with only these types allowed in there. So this is needed that TypeScript knows what to build. And we also initialize it with an empty array. Now let's start to implement this. The first thing we do is we say if the length, and now we can say equals. This does not exist in types, but we can say extends. And extends is basically, it says if this type here is assignable to this other type. So we say length extends the length of our accumulated array. Now, of course, these are just types, but TypeScript also, the compiler has to keep track of how many elements are in this array type here. So it needs such a length property. So we can check if the length here extends length, and it does not compare like number extends number, but it really compares the real number in there. So for example, if 0 extends 3, this is not the case. So in this case, we just return our accumulator, and we return it wrapped in a read-only. And otherwise, we just call our tuple again with the length, with the type, and also we now create a new array like we did here, spread our existing elements into it, and add a new type. And I will now remove this. And we can see here there is no error currently, so let's see what happened here. And we can see TypeScript created for us this tuple type, which now is read-only and is only allowed to have 3 elements in there. Now, there comes the power of this type, because we can say, of course, we can say 4 elements, but we can also say 3 or 4 elements. And it will then create a tuple which is read-only with 3 or 4 elements. We can even say we want to allow numbers, but also we want to allow strings in there. And we can see now we have now a tuple with 3 or 4 elements which allow numbers or strings. Now we can make this really, really large. We can, for example, say 999 numbers. And we can see here this creates a huge tuple for us. Now what we can't do is we cannot change this to more than 999 because TypeScript has a hard recursive stop at 999, and until then it's only any. But like some versions ago, they were like at 40 recursions. Now they stepped it up a little bit. Maybe they will change it in the future. But if you really have 1,000 or more like elements in your tuple, you maybe have to look into your code and check it either way. But I think this is a really easy way to do really complex stuff, and I think this is quite readable. Of course, you have to switch a little bit because recursion is always, I think, one of the more hard topics in software engineering, because you have to really think what happens in this recursive calls. But in my opinion, when you start using it, this is really powerful. Of course, you can do this also to create other stuff, like for example, stuff like binary trees, something like this. If you have to have certain tree sizes and so on, you can also do it like this. Now, the last thing I'd like to show you is about branded types. And when you have seen everything else I've shown you today, this is maybe stuff which is not that usable for anyone in their daily life. But the last one I will show you, I think you should really give a try, because it can make your code much better understandable, and also like your domain logic much easier to implement. So let me show you how this works. So let me switch over to the branded types. And let's say we have an email here. And this email is a string, and we say me@type.rocks. Now we say we want to send an email to when we pass in a string. So we say send email, we have our string in here, and we want to send this email. We say console log here, and we say send email to, and we have this string. Now the issue with this is, of course, that I can say send email email. This is totally fine, but I can also say send email totally not an email. And when I run this, of course, this works, and it sends send email to type rocks and send email to totally not an email. Now, the issue is, what we could do to fix this, we could add a check in here. We could add a check in this send email. But what we really want to do is that this send email's only purpose is to send this email. It should not check if this thing which was passed in is a valid email. It should know, okay, the thing I get is an email, I can send it. So what you could do is, we could say we create a function, is valid email. And in this is valid email function, we pass in a string, return a boolean, and we say return string includes, and we keep this simple here. We say an @, and then this will return true, and so we can check if this send email should be called. So we say if is valid email, we pass an email, and we wrap this. Now, of course, the issue is this one here can still be called because there is no way for us to make sure that this isValid email is called at all. But here is where we can then use branded types. So wouldn't it be nice if there was like a type, let's call this type email, and we could say everywhere we use this email type, we can be sure that this string we have is really an email. Now, where do we want to use this, for example? We could use this here because we only want to pass in valid emails. The other thing should not even compile. And the next thing we want to do is, in this isValid email, we will no longer return a Boolean, but we return a type guard. What is a type guard? Type guards are used like this. We say this, we pass in this variable str, which is of type string, and we say str is, and then we say is email. Now, what does happen here? This narrowing, this type guard narrowing, does the following. It says, okay, we have this string which is passed to this variable, and if this returns true, this means that this string here, this variable, is a string, but it's more than a string. It also contains additional properties which satisfy this email type. Now, currently we can see here this does nothing because email is just an alias for a string. So basically we say, well, if we pass in a string here and this is true, then string is a string. So there is nothing really happened here. And we can see everything still compiles as before. But here is where we can use the branded type. And this is really easy to do, but really powerful. We can say here, this is a string, and we use an intersection type for this, so it's a string, but also it has a property, and you can call this property whatever you like. I like to call this here brand, and the value is also not important, but I like to call this the same as the type. And we can see now something happened here, because send email here on line 16 does no longer compile. Now when we hover over this, we can see string is not assignable to type brand email. Now, why does this still work here on line 12 to 14? Because of our type guard. Because what are we trying to do here? We try to assign a string to this email type here. But we just pass in a string and this brand property here is missing. So this is also why it's not possible to add the type email to this const email here. Because we can see here brand is also missing. Because TypeScript sees, well, you try to assign to me a string, but I need a string and this brand property here. Now, don't get this wrong. This brand property doesn't really exist. This is just for the TypeScript compiler. Now, when you would do a console log for brand, this would return undefined because this is not really available to the JavaScript compiler, to the JavaScript runtime. But the importance here is that we can in here make sure that this send email is a valid email. Because if I hover over this, we can see here, when I change this back to string, we can see here that the email here is still a string, but as soon as it's in here, we can see it's now an email. Now, when I move this outside, we can see this no longer works because only inside of this if check, TypeScript is sure that this email string is a more restrictive kind of string and has this fake brand property. Now, why is this useful? Well, first, you don't have to create like a wrapper type. Often what I've seen is you have like a wrapper email and you have an email string in there, for example, and you then pass around this wrapper type like that it's like your domain object. The problem with this is that you then cannot use this type here or this email as a normal string anywhere. Because let's say we have a function here, let's call this function logit. And this only needs a string. Then it's really easy to call logit with my email because this is still a normal string. It's not like something wrapped which you have to unwrap or cast or something like this. You can just pass it in, and we have everything we need. We want on our email. We have on our string. We can access all the properties from the string. We can access all the functions from the string, and you can pass it around everywhere. And only the things which are interested in it being an email really will take a look into if it really is an email. So the important part here, as I already mentioned, is you can now really easy type your primitives. So you could also say, for example, another approach would be you have an integer. You say this is a number, and you say here integer, And you could then have a function which checks if a number you pass in is an integer, and everywhere you need an integer to be used, you can pass this integer type. And then you can be sure that everyone who passes you this number, that it's a valid integer. Now, something which is maybe not that nice is that you have to wrap this here in an if case, because sometimes, let's say you want to do multiple checks, you would have to do like multiple of these if checks or even nest them. Now, for that, you can create an assertion function. Let's copy that, and let's call this here, instead of is, let's call this assert. And instead of returning something and saying string is email, we say asserts string is email. And now we see here, we don't want a return anymore because this assert function just wants us to handle the case when this string we pass in is not an email. So let me show you how this works in reality. So we check if the string does not include an @ sign, we throw a new error, and we say here in a string is not an email. Now, the cool part about this is that we now don't need an if statement. We can just say assert valid email, and we can remove these braces, and TypeScript now understands that if we reach line 23, so if we reach send email here, that this email, which was still a string in there, now has to be an email, because otherwise we would have thrown an error and we would never have reached the next line. So if I move this up here, we can see the error is there again, because now it's not an email, but it's just a string. So this is especially useful, for example, if you have like a GET response or something like from an HTTP endpoint, and you need to check certain elements, and you don't want to do this you don't want to go further if there is an error in there, if there is like the data is not in a certain shape, then you could do it like this. And after that, you could then pass it to your own domain object, which has the email types or like the integer types or the for number types. And so you can make sure that you really only pass the data around in this real type it really is. So I think this is really an important thing to do if you have, like, for example, also stuff like let's say UUIDs. Like you have a string which is like in a certain shape, like a UUID. You need to make sure that everywhere you use the string, it only allows to be passed a UUID, or other stuff like phone numbers. I think it's the possibilities are like, of course, specific to your domain, but I think this is really powerful, and you can do this in not that much code, and it's also, in my opinion, really easy readable. So we have now seen map types, template literals, never type recursion, and so on. And I'd like to show you what you can do when you merge this all together. But of course, I will not code this from the ground up. I will just show you the result. And what I now show you, of course, is heavily over-engineered, so you don't have to do this, but just that you see what's possible. So what you could do is you could create some types, and the result would be that you have a validator, a validate function, where you can pass a string, and it will only compile if it's a valid arithmetic expression. So for example, in here, we can see here we have too many operands. So if I remove this, this will compile. If we have the parentheses at the wrong position, it will not compile, and so on. And this is just, of course, this is just like almost like a fever dream, but it's like you can see in this example all the things we've seen today, like map types, template literals, never, and recursion. Branded types you won't see in here, but what you also will see, and where there was not enough time to show you, is about the infer keyword, where you can extract certain elements out of an existing type. So if you're interested in going a little bit deeper into that, then I would suggest that you go to my GitHub repository, check this out, or of course you can also watch some of my videos on my channel. I also have one covering the infer keyword and many other stuff. So let's go back to the PowerPoint, and let's see, we have some time here. I'm not logged in. Let me go to type.rock/QA. This should work. So let's make this bigger. So the first thing is, have you ever used never in production? Yeah, I'm in all my code, I have like this exhaustive switches so that I don't have to worry about this. So I'm I'm heavily using this. And there's also other stuff you can do with the never type, like with that you cannot create certain strings. But yeah, I'm using it really often. What IDE am I using? I'm using IntelliJ because I mostly also program in Java, so I use the JetBrains toolbox. I'm much more fluent in there than in VS Code. Could we enforce the range? Yeah, that is the one I get always. Could we enforce the range of the values? And the sad part is that we cannot do this with, so we can enforce it from 0 to 255. But the problem is the type would get huge because it would create all the possible permutations of 0 to 225 plus the things you also append to it. But what you can do, there is also like a video of that on my channel. You have seen these intrinsic types. And these intrinsic types, like capitalize, this is something which the TypeScript compiler does not allow us developers to also add. So we are not allowed to add our own intrinsic types. But if you want to play around, I've created also a video and a CLI on GitHub where you can patch the TypeScript compiler so that you can add your own intrinsic types. And then you can create your types in JavaScript. So it's like, it makes it possible, but I wouldn't use this in production, of course. But if you want to try around, you could do this. It is also possible with normal tools, but it's really hard to do. And I wouldn't do this because the code it generates isn't really nice. How do you use types in CSS? This is mostly like, and it was most like an example to show what you can do. But I would, for example, use this in other cases when you have a DSL or something like this, where you want to only have like certain shapes of strings in there. Then I would use this. Yeah, there is also one in the. Yeah. 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 So you mean that you can't have this underscore brand in there, you mean, or? Yeah. On line 7, yeah, I cannot define it as an email, right? So, yeah. You mean, okay, yeah. No, of course, the user will all. You mean the developer that he does not see the. No, you cannot hide. Of course, you could always do stuff like as email. This is of course always used because this is like you can always trick the TypeScript compiler to because he will believe you, but it's you should not really do that. And I always tell if you're using as and then something and you are not really sure, then you are misusing the complete TypeScript type language. Yeah. Yeah. Yeah.
I was a bit confused about this recursive step where you have this tuple length.
Mhm.
It doesn't seem to me that you're decreasing the length anyway.
No,
It's not recursive.
no, I'm not decreasing the length, but I'm increasing the length of the array. So because of that, after it has iterated 3 times, because I add another element to this existing array, then it will, after 3 recursions, it will say is 3 extends 3. So I'm not decreasing the length, but I'm increasing the elements which are on there. Yeah, exactly. Oh, this is the wrong. So can I narrow the email type without using the nested code within the if? Yeah, exactly. You can use this assert function I've shown, where you can just say that you have this assert here, so that you don't have this nesting in. But maybe the question was asked prior, maybe. So is the branded type strategy considered cheating the compiler? Yeah, also, we can expect it to work in the long run because it's in there since the beginning. You can do this like since version 1.0. And it's like, it's the TypeScript compiler, its main job should be to help us write better code. And if this is something which is needed so that we can write more type-safe code, this is of course, maybe this is a little bit cheating to the compiler, but I think he will work with this. So it should not be an issue in the future, and it worked since forever, basically. Yes, you can have, maybe you can have a branded int. You can define finite ranges, but the problem with this is, of course, you don't have this in your, you could define this, but then it maybe is hard to do this maybe it's hard to do this in connection with other types, but I think this is a good idea. Maybe I will look a little bit more into this. But yeah, you could, of course, create a type like 0 to 220, call it like integer 0 to 225, and then say it will return like never or something like this if this is not a valid type. Yes, this is also something, I don't know if many of you know this. Sod is like a validation library which you can use to validate your JavaScript code. And of course you can always, and I would also suggest this if you have like if you have your data you want to check, always test this with JavaScript, not only with types. And yes, of course you could replace simple usages of the Sod validation, especially because you then see immediately because the casting, I think, to a more specific way, I think is done better with branded types than with Sod. But I'm not really deep into Sod validation, I have to say. Yeah, but plugins am I using? I'm using one to run my code is called TypeScript Worksheet. You can find it on, it's available for VS Code, NeoVim, and for IntelliJ. I've written it quite recently, and the other one is called Wit. This is for the type hints with the arrow sign and with the arrow sign. You can find it also on the JetBrains marketplace, and also I think it's also available for NeoVim, and it's called 2/queries for VS Code. This was done by someone else, and yeah, you can find it. You can find it there. Do you have any? We have to take the time. I think. Do you have to always explicitly assign these types, or can you also use these types using type inference? You can use type inference, for example, with infer. You can use this to extract some data, but maybe someone needs to more specify what exactly which case was meant. But I think we have to go on a little bit. Could create type branded type. Yes, we could also create like a branded type which is generic, which we could then use to easier create our branded type. Absolutely, we could create this utility type, which then takes our generic type and creates this for us, so that we don't have to do this manually. All right, let's go back to this and let's open this. So before we end, I'd like to thank you that you joined my talk. For all of you, wish you a safe travel. And one thing for all the people which presented here, if you could just, you can, I think, vote for the talks which you liked and disliked. And this is always important for all the speakers, so that you know which talks you enjoyed, which you did not enjoy, what we could make better, because otherwise it's quite hard to see if you enjoyed it. If you want to stay in contact, visit type.rocks or on LinkedIn, and I wish you a safe travel home. Thank you.